Good morning, Algebra 1. Today we're going to start on lesson 2-1 in our Springboard books on writing and solving equations. It can be found on page 15 in your Springboard books, so make sure you have those out before we get started today. Our learning target for the day is going to be this first bullet point here. We're going to use algebraic methods to solve an equation. More specifically, the properties that we use mathematically that can help us find what a value of a variable is. For a warm-up, I have three equations written on the board here. Okay, they're equations, not expressions, because they have equal signs here. Notice how on both sides of the equal signs I have expressions and numbers. Okay, so our warm-up for today is to figure out what number can I exactly replace my variables with for each one of these to find out what makes the equation true. Basically makes both sides equal the same. For the first one, we have 15 times x, some number x equals 60. Now, when we think about multiplication, without knowing how to approach this, this equation, let's think about our multiples of 15. 15, 30, 45, 60, 75, 90, so on and so forth. Notice how one of the numbers in my sequence that I just listed off is 60, which is the number on this side. And it's the fourth term of that sequence. That means that x has to be equal to 4. Okay. So there's our first solution right there, because 15 times 4 equals 60. Looking at the second equation, I have some number t minus 23 equals 6. Okay. So if I think about this, if I'm subtracting a number from, or if I'm subtracting 23 from a number and I get 6, that means their difference is 6. So if I go back 6 places on my number line, so 23, 24, 25, 26, 27, 28, 29, that means that that's where we would find t. So the only value that makes this true is t equals 29. And then last but not least, some number n added to 12 gives me negative 18. So in this case, because my resulting number is a negative, that means that n has to be a negative number as well. And if I think about it, I can test a couple values for n. Eventually, what I would find is that n would be equal to negative 30. And that would make that true. Okay? Now, what we're going to be doing today is we're going to be finding ways to make this process, without having to guess or visualize numbers or number lines or sequences in order, we're going to kind of make this a little bit easier where we're combining like terms and we're adding and subtracting numbers, multiplying and dividing numbers as well rapidly to solve these equations, to find what these mystery numbers could be. Looking at the top of page 15, we have a little game right here. It says, let's play guess my number, okay, or what's my number? And in this case, you get a little post-it note here that says, if you multiply me by 3 and increase that value by 5, I am 20. What is my number? So we have to find out what that mystery number is. Okay, so what I want you to do is determine that number and explain how you came up with the solution. We'll revisit this in a little bit here. Okay, for number 2, it says you may have used an equation to answer item 1. Write an equation that could be used to represent the problem in item 1. Okay, so let's talk about this. So remember, an equation means that we're using an equal sign here. And if we're basically going to translate what we have in the note card above here for number 1 into words, we're going to think of it this way. This I am right here should probably be where my equal sign is. So I'm going to go ahead and write an equal sign right here. Okay? So if you multiply me by 3, first of all, we don't know what it is, so we use a variable. Okay? Multiply me by 3. Well, that would be 3 times x. So I'm going to do 3 and then use a little dot there for x. And increase that value by 5. Increasing means we're adding. So we're going to add 5 to that 3 times x. I am 20. So I am, there's that. So on the right side, we write 20. Okay? What's my number? Well, in order to figure that out, we would have to solve the equation. Okay? And we'll get to that eventually. Hopefully, when we solve this, it comes up with the number that you came up with for number 1. So for number 3, at the bottom of this page here, for each equation, tell whether the given value of x is a solution and explain. Okay, so for part A, we have 2 plus 4 times the difference between x and 1 equals 22, where x is equal to 6. So this is just like what we saw in the previous lessons where we replace variables with values and expressions. Now we're doing 2 parts here. We're replacing the value of x into the left side expression here, but we're checking to make sure it's true. We get the same number on both sides. That's how we can tell if an equation is true. So we get 2 plus 4 times 6 minus 1, okay? And that equals 22. Let's check it out. So 2 plus 4 times 6 minus 1. I have to do 6 minus 1 first because that's in parentheses. So that means I get 2 plus 4 times 5 equals 22. 4 times 5 is 20, 20 plus 2 is 22. So 22 is equal to 22. That is a solution. Very good. Okay. Now for part B, I have 12 minus x divided by 4. Whenever we have it in this fraction form here, it's always numerator divided by denominator, top number divided by bottom number. So I'm going to it's equal to 8. So I'm going to replace x with 24. I get 12 minus 24 divided by 4. And we're going to check to see if that's equal to 8. 24 divided by 4 is 6. So 12 minus 6 equals 8. 12 minus 6 is 6. Does 6 equal 8? Well, unfortunately, one is greater than the other, so this is not true. So we would have to discard our solution of x equals 24 for a different one. All right, and the last one, dealing with decimals, they're not too scary, okay? We have 3 and 8 tenths plus 6 times the number x equals 8 and 6 tenths, where x is equal to 9 tenths, or 0.9. Okay, so we're just going to replace x with 9 tenths, so 8 tenths plus 6 times 9 tenths is equal to 8.6. Okay, so now, let's see here, so 3.8 times, this becomes 3.8 plus 6 times 9 tenths is 5, and 4 tenths. We're going to add these two together, so let's see here, 8 tenths plus 4 tenths, that gives me 1 and 2 tenths, 3 plus 5 plus 1 is 9. And once again, one value is not the same as the other. So once again, we come up with an equation or a test value that does not come up with the solution for this equation. So now we have to ask the question, what is the solution to these equations? Okay, and the way we would figure that out is we would use a series of properties, which is the focus of our lesson today, to help us figure that out. And if you notice, on the top of page 16, I believe, yep, top of page 16, in the left, where it says math tip, you see all these properties of equality. Okay, these are incredibly important. Now, it is important that you memorize these, but not to the point where you're beating yourself up over having to remember every detail. We're going to be using these properties rapidly, all the time, to the point where these are going to become second nature to remember each one of them. Okay, so there's 1, the addition property of equality, 2, the subtraction property of equality, 3, multiplication property of equality, 4, the division property of equality. Okay, so those are all my properties of equality. The rest of these are ones you may have seen in 8th grade in previous algebra classes, and those are these right here. So the symmetric property, where you can just basically switch these around. The commutative property of addition and multiplication, where you can switch the order around and still get the same thing, because you know that 2 plus 3 is 5 and 3 plus 2 is 5, so therefore we can switch those around. Same with 3 times 2 and 2 times 3. We can switch those values around and still get the same value back. The associative property is where we group different values, and it only works for addition and multiplication. And then the distributive property. This is important. If we take a value on the outside of parentheses and multiply both of what's inside, we get what's inside the parentheses multiplied by what we have on the outside. Okay, that's the distributive property. We'll need to know that for homework. All right, so at the top of page 16, we have this very, very large equation. Okay, it's pretty intense here, but I'm going to walk through this right here with you guys. So the first thing is we take a look at the original equation, which is 3x plus 90 plus 2x equals 360. This is the original equation. In the next line here, we're going to take this 90 plus 2x and apply the commutative property. Remember, commutative property says we can switch the order of any two terms that are being added. So that's what we do right here. The next thing we do is we combine the 3x and the 2x because they are like terms. They both have an x. We have 3 x's, and then we have 2 more x's. That gives me a total of 5 of them, which is what results here. Okay? Now the next thing we want to do is, because we don't know what x is, we want to be able to eliminate as many non-x terms as possible. So the only non-x term we have on the left side is 90. Okay, because it's a positive 90, I'm going to subtract using the subtraction property of equality to make this 90 go away. Now, an important property, general property of an equation is that whatever you do to one side of the equation, you have to do to the other. So where I subtract 90 on one side, I also have to subtract on the other. Now, this helps out because 90 minus 90 is 0. So these 90s will go away just like that. And then I can combine 360 and 90 to get me 270. Okay? Now remember, this is 5 times x. So I have to use division to get to this final point here. So 270 divided by 5 is 54. Now 5 divided by 5 is 1. Therefore, when I have 1x, or 1 times x, I can just leave it as x because 1 times any number is itself. And here's how we check our solution to make sure it's true. Like we said, we replace wherever we see an x with our supposed solution. Okay? So 3 times 54 plus 90 plus 2 times 54 equals 360. 3 times 54 is 162. 2 times 54 is 108. And then we can combine all 3 of these numbers here and see that absolutely 360 is equal to 360. We've proven with this equation and using these properties how we can get to the solution of an equation without knowing or just guessing. Okay? So this is going to be where we're going to stop for today. Your homework is on delta math, and all it is you're going to be getting familiar with the properties that we've seen here today. Okay? And then we're going to also be looking at the try these on the bottom of page 16, where it says try these A. Your homework is going to be in there. Make sure you check the hyperdoc to complete your homework. I'll explain that in detail when we get to class. I'll see you guys later. Have a good day.